The vast universe holds countless worlds beyond our solar system, each unique in its own way. Yet, among the thousands of exoplanets discovered, none rival Earth in suitability for human life. Our planet offers ideal conditions, mild temperatures, a protective atmosphere, and abundant water, while many exoplanets lack these crucial elements. Some are scorched by extreme heat, their surfaces molten or barren deserts. Others remain frozen, too far from their stars to sustain warmth, or endure intense radiation from red dwarfs and giant stars. Despite these harsh conditions, some exoplanets show potential for life. Vast oceans, flowing rivers, drifting clouds, and nourishing rainstorms suggest environments where life might exist, though possibly in unfamiliar forms. Exploring these distant worlds not only deepens our understanding of the universe, but also fuels the hope of one day finding a second home for humanity. Life is a complex and mysterious phenomenon that humanity has yet to fully understand. One of the greatest questions we face is whether life is common in the universe or if it exists solely on Earth. If Earth is the only place where life has emerged, it means our planet possesses exceptionally rare and unique conditions. However, if life is found elsewhere, it would transform our understanding of humanity's place in the vast cosmos. This is why the search for extraterrestrial life has become one of the most crucial fields in modern science. Scientists are not only looking for microbial life within our solar system but also studying exoplanets in habitable zones around other stars. These discoveries provide valuable insights into the nature of life itself and offer clues about the conditions necessary for its existence. If evidence of extraterrestrial life, whether simple bacteria or more complex organisms, is found, it would prove that life is not a rare anomaly but a natural outcome when the right conditions exist. Moreover, this search is not just about scientific curiosity, it holds profound significance for humanity's future. Understanding life's potential beyond Earth could guide our efforts to find a new home in case our planet becomes uninhabitable. Exploring other worlds may one day be essential for the survival of our species, making the search for life beyond Earth more than just an exploration. It is a mission for the future of humankind. The Earth Similarity Index, ESI, is an important measure that helps scientists assess how closely an exoplanet resembles Earth and whether it has the potential to support life. This index is calculated based on various physical factors, with two key ones being surface gravity and equilibrium temperature. Surface gravity reflects a planet's geological conditions and its ability to retain an atmosphere, while equilibrium temperature helps determine whether the planet is within the habitable zone, where temperatures allow liquid water to exist. However, while ESI is a useful tool, it has several limitations. It does not take into account crucial factors such as atmospheric composition, magnetic fields, the actual presence of liquid water, or other essential conditions for sustaining life as we know it. For example, a planet with a high ESI might still be unsuitable for life if it lacks a protective atmosphere or is exposed to extreme cosmic radiation. Additionally, ESI does not reflect the complexity of ecosystems or the specific chemical elements needed for life to develop. Therefore, although ESI is valuable in identifying potentially habitable planets, scientists must use a combination of different methods to gain a more complete understanding of a planet's ability to support life. The search for life beyond Earth requires a broader perspective, one that goes beyond numbers and statistics to truly uncover the conditions that make a world livable. To accurately assess the potential for extraterrestrial life, scientists need to expand their evaluation criteria beyond the Earth Similarity Index, ESI. One crucial factor is the activity of the host star. If a planet orbits a star with intense solar storms or unstable radiation levels, its atmosphere could be stripped away, drastically reducing its ability to support life. In contrast, a stable star with moderate radiation provides a more favorable environment for life to develop. Another important consideration is the likelihood of tidal locking. If a planet always has one side facing its star, one hemisphere would be scorched while the other remains frozen in perpetual darkness, creating extreme conditions that make life difficult. However, in certain cases, if the planet has a thick atmosphere and efficient heat circulation, a temperate region could exist along the boundary between the light and dark sides. Additionally, the planet's type and chemical composition play a vital role. Rocky planets or super-Earths, larger than Earth but still with solid surfaces, are more likely to retain an atmosphere and liquid water than gas giants or ocean worlds lacking essential elements like carbon, nitrogen, and phosphorus. By integrating these expanded criteria, scientists can gain a more accurate understanding of which exoplanets may truly have the potential to host life. Gliese 1002b is one of the most promising exoplanets in the search for life beyond Earth. Located about 15.2 light-years from our solar system, this planet orbits the red dwarf star Gliese 1002 with a short orbital period of just 10 days. Due to its close proximity to its host star, Gliese 102b is likely tidally locked, meaning one side is always facing the star while the other remains in perpetual darkness. This could create extreme temperature differences, but if the planet has a thick enough atmosphere and efficient heat circulation, liquid water could still exist in the twilight zone between the two hemispheres. One notable aspect of Gliese 1002b is its size and gravity, which are similar to Earth's. It has an Earth Similarity Index, ESI, of 0.86, a relatively high score among known exoplanets. This suggests that, at least in terms of physical conditions, the planet may have the potential to support life. Furthermore, based on climate and geological models, Gliese 102b may have oceans or continents in its sunlit region, where temperatures could allow liquid water to exist. If its atmosphere contains key compounds such as oxygen, carbon dioxide or methane, the chances of life emerging increase significantly. While more data is needed to determine its exact environment, Gliese 1002b remains a strong candidate in the ongoing search for extraterrestrial life. Gliese 102c is the second discovered planet in the Gliese 102 system, located about 15.2 light-years from Earth. With an orbital period of approximately 21 days, Gliese 1002c is farther from its host star than Gliese 102b, meaning it receives less energy. As a result, its surface temperature is extremely low, estimated to be around 91 degrees Celsius, similar to the icy moons of Jupiter and Saturn in our solar system. Despite its harsh temperatures, Gliese 1002c remains a compelling candidate in the search for life, particularly beneath its thick ice layer. Many scientists believe the planet could harbor a subsurface ocean, much like Europa, Jupiter's moon, or Enceladus, Saturn's moon. If there is internal heating from geological activity or tidal forces, liquid water could exist beneath the frozen surface, creating a potential environment for life to emerge. Although much is still unknown about its atmosphere and chemical composition, Gliese 1002c remains a key target for studying the possibility of extraterrestrial life. Exploring this world further could provide valuable insights into how life might thrive in extreme, icy environments beyond Earth. K2-72e is an exoplanet located approximately 27.1 light-years from Earth, orbiting the red dwarf star K2-72 with a period of about 24 days. What makes this planet particularly intriguing is its estimated average temperature of around 20 degrees, an ideal range for liquid water to exist on its surface, potentially creating a habitable environment. However, K2-72e's host star is a red dwarf, known for its intense solar storms. Powerful stellar winds could erode or even strip away the planet's atmosphere, removing a crucial protective layer necessary for sustaining life. If K2-72e possesses a strong magnetic field or a thick atmosphere, it might be able to shield itself from these storms and harmful radiation. One fascinating hypothesis about life on K2-72e is that plants, if they exist, might have evolved a different method of photosynthesis. Since red dwarfs emit dimmer, infrared heavy light, vegetation on this planet could have purple or red leaves to absorb energy more efficiently. Additionally, any potential life forms may have adapted to high radiation levels by developing protective outer layers or specialized DNA repair mechanisms. Although much remains unknown about K2-72e, it stands out as one of the most promising exoplanets for studying the potential existence of life beyond Earth. Kepler 452b is an exoplanet located approximately 1,800 light-years from Earth, orbiting the yellow dwarf star Kepler 452, a star remarkably similar to our Sun. It is one of the most closely studied planets in the search for potentially habitable worlds. With a radius 1.5 times and a mass about 5 times that of Earth, Kepler 452b is classified as a super-Earth. Its surface gravity is estimated to be 2.2 times stronger than Earth's, which could pose challenges for large organisms. If life exists there, creatures might have evolved unique adaptations, such as thicker bones or reinforced exoskeletons to withstand the higher gravity. Scientists theorize that Kepler 452b may have vast shallow oceans, providing an environment where aquatic ecosystems could flourish. If the planet has continents or landmasses, vegetation might grow similarly to Earth's, given that it receives sunlight from a sun-like star. This suggests that, if plants exist, they could be green, using photosynthesis in much the same way as on Earth. Although many mysteries remain about Kepler 452b's atmosphere and surface conditions, it remains one of the most promising candidates in the search for extraterrestrial life beyond our solar system. Although scientists have discovered many exoplanets with characteristics similar to Earth, there is still no definitive evidence of extraterrestrial life. Some distant worlds have the right temperature, atmospheric composition, and liquid water, key factors for supporting life. But no planet has been confirmed to actually harbor life. While the search for habitable planets continues, Earth remains the only known world where humans can live. It is not just a planet that supports life, but one that has evolved perfectly to sustain humans and countless other species for billions of years. No matter how Earth-like another planet may seem, it would still be an unfamiliar and challenging place for us. Migrating to another planet is not a simple or realistic solution in the near future.